Assalamualaikum, my name is Azizul Hakim bin Ahmad Pandi and my ID number is MA22129. So for the introduction, firstly, I will present about the project overview. The Catapult project is a hands-on engineering activity aimed at designing and building a functional catapult using recycled materials such as popsicle sticks, rubber bands, and spoons. The goal is to launch a ping pong ball to a target distance at exactly of 100 cm with high precision and accuracy. This project integrates the Six Sigma approach, a data-driven methodology used to minimize errors and variability in performance by applying the Six Sigma phases, which is define, measure, analyze, improve, and control, which is DMAIC. The project emphasizes continuous improvement and quality in mechanical design. Next, for our objective, first, it is to design and construct a functional catapult using only allowed recycled materials. Second, to apply Six Sigma principles such as data collection, analysis, and continuous improvement to optimize our design. And last but not least, to ensure our catapult consistently launch a ping pong ball at a target of 100 cm away, which will demonstrate both accuracy and precision. So now for the scope of the project, this defines what we are doing, what we aim to deliver, and what limitation we face. So firstly, for the specifications, we aim to hit a 100 cm target. Our acceptable range is between 90 cm and 110 cm. This range represents our lower and upper specification limits, LSL and USL. This means any launch within this range will be considered successful. Next, for the deliverables, the main deliverable is a working catapult that is consistently meets these specifications. It should be able to launch a ping pong ball to the target distance with minimal variation between trials. So, last but not least, for the limitations, we have two limitations. First is materials. We can only use recycled items such as rubber bands, spoons, and popsicle sticks. No advanced tool or mechanical parts are allowed. The second is we have only 4 weeks to complete the entire process, including planning, building, testing, and final improvement. And despite these constraints, we aim to balance innovation with practicality while still applying Six Sigma mindset of improving quality through measurable units.
Okay, now moving on to stage 1, where starting on the left, we observe that the process mean is 116.2 with a standard deviation of approximately 22.44. The lower and upper specification limits are set at 88 and 146, right? And then based on this, our process capability indices shows a CP of 0.43 and CPK around 0.42. And the Z-score values are 1.26 and Z3 CPK value is 1.26. Also, this reflects there's a room for significant improvement in quality performance. On the right-hand side of the slide, we break down the cost of poor quality COPQ. The manufacturing cost of 24,000 units are 187,000 ringgit 200. The rework cost is around 36,000 and the scrap cost comes up to 151,680. So this results in total COPQ of 187 ringgit 680 and overall total cost of 374,880 ringgit. This analysis tells us that poor process capability directly contributing to high rework and scrap costs. Thank you. Now, moving on to stage 2, this slide outlines the targeted improvements and projected outcomes. Our goal is to improve the process capability indices, setting both CP and CPK targets at 1.0. This would bring the process much closer to the industry standard for a capable and stable operation. Currently, our cost of poor quality COPQ is at 187,680 ringgit. With the planned improvements, we aim to cut this by half and bringing our target COPQ down to 93,840. This results in an expected annual savings of 93,840 ringgit, which is quite significant The cost to implement these improvements is 60,000 ringgit. And based on that, we estimate an ROI of 156.40%, which is a highly promising return. Even more encouraging, the expected break-even duration is 0.64 years or roughly 7 to 8 months, meaning we will start seeing net gains within the first year of implementation. That's all for stage 2. Thank you.
I'll be presenting stage 3, which focuses on applying the DMIC framework to improve business process. Um, we begin by identifying the main issue, a high COPQ, mainly due to excessive rework and scrap rates. Our objective is to cut the annual COPQ from 187,680 ringgit by 50%, bring it down to 93,840 ringgit while enhancing process capability, targeting CP and CPK values of 1.0. In the measure phase, we collected data on defect rates, process capability indices, improvement costs. This revealed a 30% rework rate and 40% scrap rate at this stage. CP and CPK were at 0.2293 and 0.1247, indicating significant room for improvement. For the next stage is analyze. Further analysis confirm our findings. The same high rework and scrap rate, low process capability indices. This reaffirm the need for robust corrective measures to enhance quality and reduce waste. For the improved part, several initiatives were implemented. Six Sigma training for selected employees, SPC implementation for real-time process monitoring, equipment maintenance and adjustments, and improved supply management. The improvement budget was 30,000, which included 10,000 ringgit for an in-process inspection, 5,000 ringgit for SPC tools, 5,000 for maintenance, 10,000 ringgit for training and adjustments. This step has helped us ensure a systematic data-driven approach to improvement. For the control part, to sustain the improvement, we implement the following control mechanisms. Control charts to monitor parameters, which cost 5,000 ringgit. Regular audits to ensure compliance, 5,000 ringgit. Feedback loops for operator input, 5,000 ringgit. We also standardize operations by updating standard operating procedures, which cost 5,000 ringgit, and keeping detailed documentation of all changes, which cost 5,000 ringgit. The next is the outcomes and ROI. The result, process capability improved, targeting CP and CPK of 1.0. COPQ was reduced by 50%, saving 93,840 annually. The return on investment stands at 110.4%. The break-even period is estimated at just 0.91 years.
In stage 4, we will determine whether the two different samples will have the same population variances and the same population means. Other than that, this stage we will involve analyzing the cost of poor quality (COPQ) and assessing the process capability. So we will have 10 samples for each category as shown in the table. Anyway, we don't know whether the two sample data set whether have same population variances or not. So we conduct a hypothesis testing to determine whether the two population variances whether are same or not. So we conduct the hypothesis testing and the output is obtained by using the Microsoft Excel. So our null hypothesis is two populations variances are equal. For alternative hypothesis is two population variances are not equal at alpha equals to 0.05. Based on the Microsoft Excel output, the summary is the p-value is 0.33, which is larger than the value of alpha 0.05. So we can conclude that we should not reject the null hypothesis H naught. In other way, the practical meaning is the variances between the two groups are equal. Since we already know that the population have equal variances, now we can conduct another hypothesis testing to test whether the two population means are equal or not. And we will get the output from the Microsoft Excel correspondingly. Based on the Microsoft Excel output, the p-value is 0.1755, which is larger than the value of alpha 0.05. So we can conclude that we should not reject the null hypothesis H0. In the other way, the practical meaning is the mean between the two groups are equal. Next, we will move to the process improvement analysis, which is about cost of poor quality COPQ and process capability, and also will involve the achievements in defect reduction, cost savings, and ROI. Now, let's look about the key improvements. For the defect rate reductions, rework rate reduced from 30% to 15%. Scrap rate reduced from 40% to 20%. For the annual demand is 24,000 units at 7.8 for each unit. Here, you would like to compare the cost of poor quality COPQ for each category. For rework cost, initial COPQ is 28,080 ringgit. For the new COPQ, it is about 14,040 ringgit. For its savings, is about the same, which is also 14,040 ringgit. Meanwhile, for the scrap cost, initial COPQ is about 74,880 ringgit. For the new COPQ, it costs 37,440 ringgit. For its savings, also same, 37,440 ringgit. So for the total COPQ, initially is 102,960 ringgit. For new COPQ is about 51,480 ringgit, same as the savings. Next, let's have a look for the process capability matrix. For the value of CP is about 0.43, which remains unchanged, while for the value of CPK is 0.33, which has a improvement from 0.33 to 0.54. While for the Z score initially is 0.98, now it is getting better because the Z score is higher from 0.98 to 1.61. So we can interpret that the process capability remains limited since for the CP value is less than 1, but it shows that marginal improvement in centering CPK. For financial impact and ROI, the total project cost 38,000 ringgit for personnel, training, equipment, and materials. Annual savings is about 51,480 ringgit. ROI is 9.53%. For the break-even period is 0.91 years, approximately to 11 months. Next, we move to the summary for this stage 4. The successes is 50% reduction in COPQ, where the 51,480 ringgit is saved annually. Other than that, it improved the process alignment with higher CPK. Next steps, address CP to reduce variability. We should target the CP larger than or equal to 1.33. So it sustains gains with continuous monitoring.
Okay, Assalamualaikum. My name is Wan Muhammad Alif bin Wan Muhammad Jailani and my card matric number is MA23080. So I would like to summarize the overall project that we have been done. So our goal is to reduce cost of poor quality COPQ from rework and scrap. And the method we use is DMAIC. define, measure, analyze, improve, and control. And the third one is initial finding. Initial finding is high cost due to poor quality, and then action identify defect and improve process. And the last one is result. So the result better performance and lowest defect rate. Okay, the next slide is implication of the result. There are 2 points. The first one is process capability and cost and benefit. Initial and defect rate was high. After improvement, the CP is 0.343846 and the CPK 0.2894. This show the progress, but the process still need better control to meet quality tolerance. However, the cost and benefit is initial COPQ have 102,090 and reduced COPQ is 51,480. Significant cost saving after process improvement. Okay, challenge and recommendation have four. The first one is data collection and accuracy. The second one is chain resistant, and the third one is maintaining consistency. And the last one is training need. For data collection and accuracy, we can say the difficult to gather reliable data during early phase. However, the chain resistant, we can say the some staff were reluctant to adopt process-based method. And then the maintaining consistency, ongoing effort needed to sustain improvement and monitor quality. Emphasize continuous feedback adjustment. The last one is training need. Our worker requires proper training for new system and tool. Okay, for recommendation, there are 4 points. The first one is continuous monitoring. Continuous monitoring is set up strong tracking to measure process performance and spot improvement area. The second one is employee engagement. Employee engagement is to involve staff at all levels to reduce resistance and build a quality focused culture. The third one is advanced training. Advanced training will provide ongoing training to keep skill updated and improve efficiency. And the last one is enhanced data analysis. Use modern tools for better process ever evaluation and decision making. Okay, for my last slide is about conclusion. So I would like to conclude for what we have been done for our project. The project helped to reduce reward and scrap, lowering the cost of poor quality. And the second one is using the DMAIC method to improve the process in a structured way. The company save money and gain a good return on investment. However, the process still need to improve to meet a good quality standard. The last one is to keep improving. The company should monitor about the performance and train staff and involve employees more. That's all from me. Thank you.